Next, let's take a look at example 3. So we're going to solve a linear trigonometric equation. So we're going to solve the equation 2 sine of theta plus the square root of 2 equals 0, given that our theta has to be between 0 and 2 pi. So if I have 2 sine of theta plus the square root of 2 equals 0, what's the first thing I might want to do? Well, for example, if I had 2x plus the square root of 2 equals 0 and I told you to solve for x, you'd know, yeah, I got to move that square root over. So we're going to do the exact same thing here. So I have 2 sine of theta equals negative square root of 2. Next, to get sine of theta by itself, I'm going to divide by 2. So I have sine of theta equals negative square root of 2 over 2. So I go to my handy dandy unit circle and I say, okay, unit circle, where is sine of theta? Negative square root of 2 over 2. That's going to be where our y values are negative. So I'm going to be in quadrant 3 or 4. So my options are 5 pi over 4 or 7 pi over 4. And I just got all of that from our unit circle. Let's work through another example. So for example 4, if I have sine of 2 theta equals the square root of 2 over 2, how am I going to solve this? Well, I know that 2 theta has to equal, the sine of 2 theta has to equal the square root of 3 over 2. So where is the square root of 3 over 2 sine of theta? So sine of theta is the square root of 3 over 2 at pi over 3 or 2 pi over 3. But I'm not taking the sine of theta, I'm taking the sine of 2 theta. So I have 2 theta equals pi over 3 or 2 theta equals 2 pi over 3. If I divide both sides by 2, I get theta equals pi over 6, or theta equals pi over 3. Now that's the way I decided to solve it. You could also use inverse sine. So if I have sine of 2 theta equals sine of equals the square root of theta. Nope, not the square root of theta. Equals the square root of 3 over 2. And I take sine inverse of both sides. I would get that 2 theta equals sine inverse of square root of 3 over 2. And that has two possible values of pi over 3 or 2 pi over 3. And that's another way to solve for theta. For example 5, we're going to solve a trigonometric equation. So I want to find tan of theta minus pi over 3 equals the square root of 3 over 2. So tan is positive. Oh, sorry, equals 0. That's supposed to be an equals 0. So tan is of theta is positive. So we're in quadrants 1 or 3. Those are our only possible quadrants. And here, we wouldn't want to use tan inverse because tan inverse isn't defined in quadrant 3, or arctangent if you want to call it that. Now I know that tan, I want to know what theta gives me the square root of 3. That's supposed to be this problem. I'm so sorry, guys. This is tan of theta minus pi over 3 equals the square root of 3. Okay, so now I want to know for what theta does tan of theta equals the square root of 3. And that's going to be at theta is 4 pi over 3 or pi over 3. But I'm not just looking for tan of theta, I want theta minus pi over 3. So I'm going to take 4 pi over 3 and set it equal to theta minus pi over 3. And I'm going to take pi over 3 and set it equal to theta minus pi over 3. And after I add pi over 3 to both sides twice, I say I get the answer 5 pi over 3 is our theta. So if we substitute in, we would get the square root of 3. And if I get 2 pi over 3 is also theta.